lady. Amazing. Welcome everyone to Tools for Thought Rocks, a special session in April 2024, which is roughly 13 months after we've had the last one of these. This is an open community that tends to host talks exactly like this, typically virtually. Myself and Jess Martin are the two volunteer organizers. If you'd like to get involved, please let me know. And what do we talk about? Digital gardens, second brains, spatial canvases, and other tools for thought. This is 13 months ago, so there's no mention of LLMs in here. But I think things like that are definitely in scope as well. And kind of our main gathering spot is the Luma calendar. If other people have related events, we're happy to host them and share them on there. You're also welcome to organize your own talks like this. I'll happily help set you up. And we can use my paid Zoom and a few other things like this. And we've got, I think, about 500 people on there who are interested in this as a topic. Event recordings on YouTube. Jess has looped someone in to get some help to put together a talk archive. So that will at some point be at toolsforthought.rocks. We do have a little mini open collective. Bill, among others, is on a Tools for Thought Mastodon server that we have. Small crew, but fun stuff. For this talk, we are going to be using hand protocol. So mostly stay muted. If you'd like to make a comment or ask a question. Orion, do you want your things live or held for the end?
Live or held for the end?
For questions that people have, do you want them held until you're done your talk, or would you like them in line as you're speaking?
Good question. What's the time on this call? How much time do I have?
You have about an hour, and then we run over with a hardcore crew for as long as people stick around.
All right. I think either is fine.
I'll help MC for it anyway, and we'll make sure things don't go too long.
How about that? Like I trust you to like interject if there's something that comes up in the chat or something. Yeah, let's do that.
Amazing. And so this came about because Orion presented his talk at a Causal Islands community event that I hosted in LA that was really, really great, for a really, really great talk, a really great collection of people, but we weren't set up and sponsored to do full video and audio recording of everything. And we really wanted to get a recording, so I invited Orion back on and say, let's do this for anyone who can't be places in person, and we'll get an awesome talk. And with that, I will hand it over to Orion.
Sweet. All right, let me share my screen here. Nice to see so many familiar faces in the chat. Got quite a turnout. All right. Now, do I remember how to use Keynote? Let's find out. All right. Is everyone seeing my screen?
Yep.
All right. I guess I can get started here. So yeah, this talk is about spatial canvases, kind of, but it's really about this idea that we could or maybe should think about developing an integration domain for human-computer interaction, and that maybe spatial canvases have a useful role to play in that. I'll get into kind of what that term means. So yeah, here's a little outline. Got a bit on software interfaces, information substrates, which is the second idea that I'm pulling into this. Some demo stuff. This idea of an integration domain for human-computer interaction, and then I've got this one idea that I've been mulling over at the end, which if we need to, we can cut for time. So let's talk about software interfaces. So I think, you know, we're all very familiar. Like, I'm sure everyone here uses computers, right? If you didn't, you wouldn't be here. And all of our interfaces look a little bit like this, right? We have windowing systems as part of our operating like systems. They have a kind of a set purpose. Like you got your app for music, you've got your synth tools, you've got your tool for managing papers and so on and so on. And so the kind of the state of affairs right now is that these interfaces are really quite rigid. You can't change them very easily. They're siloed in that they don't really talk to each other. That you can't point your, I don't know, your iTunes, your Apple Music app at Spotify and have it coordinate what songs you have in playlists and so on. And they're mass produced in the sense that we kind of have this model of production where it's a kind of one size fits all, where we try and make software that fits the needs of everyone in a kind of abstract sense. So a different kind of direction to try and push this comes out of this work on malleable software, which has a history back to kind of tailorable systems and other research. And a part of this kind of picture of software being malleable is imagining that you could really kind of pull apart your interfaces at the level of individual UI elements. So not just malleable in the kind of like back-end sense of having flexible APIs and such, but the full stack all the way from the systems you're interacting with to the elements that you have on screen being kind of amenable to change, not by programmers, but by ideally everybody. And so one way to look at this is this kind of topological view, right? That the current way, oh, hey cat. There's going to be some meows in the background. There's a kitten here that's joining in. So yeah, the way that we currently produce interfaces, it really incentivizes this kind of topology of software that we have, right? Where you have people on the one side, they interact with software through some kind of interface. And that interface and the system or systems it's interacting with, like its backend, say, are really kind of tightly coupled. You could think of it as like you have a bunch of machinery and you slap a kind of a control panel on the top. And part of what I'm going to try and argue here is that we've made less progress than we could have on the interface side, and that actually progress there could help make software more broadly easy to change, even for people that don't care about interfaces. So if we scale this up, we can kind of see our experience of computing as broadly this kind of relationship to apps and these kind of appliance like things where each has dedicated interface, a dedicated a set of features, and then through those you get to interact with the kind of substrate of computation. There are some variations on this though, so yeah, we can call this like the app paradigm of software. It doesn't particularly matter what you call it. So yeah, another model, and let me try and move the Zoom thing so I can see my slides. So another model might look a bit like this, where you have a really big interface to many systems. And this is kind of what we're familiar with on cloud platforms. If you've ever used Google's developer console and stuff, it's like this one central interface to a million different things, and it's really massive. That's one way we can go with this. Another that I think is nicer in many ways is this kind of bring your own client model of software. So you could take email as an example, where you have some underlying protocol, but you can build many different interfaces on top of that protocol. And so you give people some degree of choice as to kind of which interface they pick. But even the bring your own client model still kind of ends up with a similar topology of you have these kind of discrete, closed, rigid apps or interfaces, and they can't easily talk to each other. You can't really remix them in a way that suits your needs. So this is kind of the first argument, right? That like taking this topological view, this kind of relationship between the interfaces to software and the systems or the software itself is kind of holding us back. And to change this and to kind of achieve these aspirations of malleable software and to some extent local first software and stuff like this, we need to change the way that we are doing interface production, though they were actually making these interfaces. All right, so we'll talk now about canvases and information substrates, which is in the title of this talk. So if you're not familiar, a spatial canvas is kind of any of these things, right? It's a whiteboarding tool, or it's a node and wire interface. So from left to right here, we have like Excalidraw for whiteboarding stuff. We have Reactor for building synthesizers for doing music production. Blender Node is a system to do kind of procedural it's a programming interface for shaders and geometry and stuff like that. TLDraw, like Excalidraw, is kind of for whiteboarding, diagramming, that kind of stuff. Stately, builds state charts. And we can kind of think of this abstractly as you have some set of objects, they have a position in this shared Euclidean space, and a lot of the time you'll have relationships between them. So unlike something like Photoshop, where you're maybe drawing with a brush or something, in almost all canvas tools, you can express relationships between those objects, like you can draw arrows between them and such. So then we have this other idea of information substrates. This came out of Michel, unpronounceable middle name, Lafon. And information substrates, and again, I will try and move my, oh wait, maybe I can't see, wait, hold on. Let me just do this and make the make that smaller. All right, and we're back. So an information substrate, we also move the cat, sorry buddy. We can think of as it's this kind of this computational medium that holds digital information. So one of the kind of key insights of this idea is that data doesn't really exist in a vacuum. I think we have this on this next slide. For context, if you can't see it, right, like this is on the left, we have layers like you might have in Photoshop or Figma or other tools, a timeline view that you'd have in music production or video editing tools, and then a spreadsheet and its kind of underlying like dependency graph. And the insight here is really that data, it doesn't exist in a vacuum. And in these cases, when you have a substrate, it's not just a data structure, right? It's something a bit richer than that. So it's this substrate analogous to the physical substrates that we have for biological life, that provides context for interpreting the data, constraints for presenting and interacting with it, is the crux of this idea. So if we look at canvases through this lens, we can really see them as something different from kind of tools, like a tool for whiteboarding, say, or diagramming, but we can look at them as information substrates, right? So they have all the criteria that we need there. They define constraints on data, they have context for its interpretation, and a means of presentation and interaction. And to kind of illustrate this, I'll switch into a demo here. All right. Can everyone see this screen? If people are doing thumbs up, I can't see.
Yes, looks good.
All right, sweet. So this is TLDraw here, which is one of these canvassing tools. You can do all the familiar stuff. You can draw on it. You can make boxes. You can make arrows between boxes and so on. And so I decided to kind of mess around with this. And so we can, for example, let's just make some boxes here. And we can, for example, take these kind of entirely absolutely positioned elements and give them a kind of physicality. So here we have effectively collision detection. And so they have a kind of an inside that can't overlap, it can't occupy the same space as other elements. And it's very fun to move objects around that way. So we can then also take these elements, and if we make some kind of rough like structure, let's do, I don't know, let's do that. We can then untangle that diagram and kind of augment this quite static representation with more live interaction. And to kind of give an example of where this is useful outside of just kind of diagram layout, one of the things that it helps to solve is keeping things legible, right? Like if you want to have content here that is legible and you don't know what that content will be, something like a graph layout can help in making sure that it doesn't overlap. So for content, we could, for example, do something like this, where we just stream in a response from an LLM. That by itself isn't too interesting. But we could, for example, take a color. So here, this green color, I basically mapped it to a knowledge base query of like at Block Science, one of the places that I work. And so now we can take the same idea, let the graph layout drive this. Sorry about the car horn in the background. And now if we hit this, it's basically going to do the same thing with the graph layout driving the sizes and kind of positions of the nodes. It means that we're not going to get any overlap, and it's going to be able to kind of to adapt to this. And then on top of that, there's this very kind of straightforward DAG dependency based execution model that we have there. So we can do this kind of stuff. Something else we can do is, let me just set this up real quick, and hopefully this works. All of this stuff was being tweaked moments before I got on this call. So we can also, because you have geometry, you have positions, you have everything you need to do physics simulation. So here is the same canvas, but now we're doing a full physics sim with bouncy objects, non-bouncy objects. We can have you can move these objects around. It remains interactive. You can also, whoop, hold on, hold on, wait, let me delete that guy. Let me just move this over here. So you could take a shape. Hi. Hey. Hello. You could take a shape, and let's make this one purple, and similar to the other stuff, we're just kind of binding visual state to other things. So in this case, when I add this back into the physics simulation, purple is basically becomes a character that you can walk around on the diagram. But I think where this starts to get a little more interesting is where you can actually kind of have these systems coexisting, right? So here we have this graph, and if we bring it down over here and drop some objects on it, we're going to see that this graph being driven by a force directed graph layout system is kind of coexisting with this physics system pretty happily. And you could, of course, walk across that, although I didn't implement a way to actually move the character. So I'll just bring this guy down here, give us a little step up, and then we should now be able to very awkwardly walk onto a diagram, and then we can walk around a diagram and do all kinds of fun stuff there. So what this is hopefully illustrating, this cat is going to be a recurring guest. Well, this is hopefully illustrating, if I come back to my slides, oh, those aren't my slides. If I come back to my slides, so yeah, what I'm trying to kind of get at here is that looking at canvases as not kind of tools with a specific use case necessarily, like not necessarily for diagramming or for writing shaders or all that kind of stuff, but looking at them from this kind of substrate perspective, it kind of gets to some interesting outcomes that you don't maybe associate with these kinds of canvas tools. So hopefully that helped kind of illustrate that point.
So are you are you thinking of this? I mean, you showed it earlier. So I'll maybe try and draw it out a bit. you would like to present Canvas as a similar substrate as the spreadsheet.
Yes. Yeah. But like as a substrate in the same way that a spreadsheet is also a substrate. Um, and another way of saying that is it's kind of looking at canvases as a representation instead of as a tool.
Awesome.
So they're in there with these other representations, and for reasons we'll get to in a second, I think they have some kind of unique properties that could be really useful when it comes to thinking about how we're producing interfaces for our software. So the second idea that's kind of important for this is this idea of an integration domain, specifically an integration domain for human-computer interaction. So this concept comes from Stephen Kell in his paper on the mythical matched modules, which is a good read. And I think the easiest, most succinct way of introducing this idea is through this analogy, right? So if we take a different field like electrical engineering or circuit design, we can kind of notice that the production of individual components like integrated circuits is a separate thing from integrating those ICs into bigger systems. And importantly, that kind of process of integration has its own set of vocabulary, as he calls it here, of kind of glue components and ways of composing things together. In a way that we don't have for software. I can imagine there are some things that come to mind of coordinating like Docker containers and stuff like that. I won't go into the depth of this idea that it deserves, but I think he makes a good case for us really not having much of an integration domain at all for how we make software. And so a succinct way of understanding this is that an integration domain is really just a set of languages and tools for performing the integration of software. And so my question here is, can we imagine an integration domain, not for software as a whole, but specifically for interfaces and interaction? I think we can, but I'm happy for that to be an open question and to hear what people think about this. And the kind of the follow-up question, for this talk is, can the spatial canvas evolve into something suitable for this kind of integration? And we could think of this as a kind of UX or UI integration substrate, which is to say an information substrate that is amenable for this process of integration, which I think is relevant in a way, relevant for interfaces and interaction in a way that it's not for software more broadly. So jumping kind of right into a few reasonably small things that I think we can do to push it in a useful direction for this. One is having some way of defining sets of objects, right? So if you have a canvas, you have n objects in it, you need to be able to define subsets of that so you can refer to them and bind them to systems. So I built a very small proof of concept of that just in TealDraw. Not to be clear, none of the demos I'll be doing are really going to be demos of what I'm proposing, because they can't be. It's an inherently more kind of collective endeavor. But I built a kind of a proof of concept system of just this kind of collection like primitive in TealDraw, and that made it pretty trivial to have the graph system and the physics system kind of coexisting. And so another one is regions. So canvases normally are basically like infinite or sometimes bounded empty Euclidean space, and anything else in that needs to be defined in terms of like tools acting on that space or objects within it and so on. I think it's important to have some kind of way of slicing up that empty space so you can define this kind of generic notion of a geometric inside, and this becomes important when we want to talk about kind of integrating UI together. from many different places for many different purposes. So the third one here is this idea of geometric encapsulation, this is absolutely not the default for all of these tools right now. But the idea is analogous to encapsulation in programming, that we can imagine the objects in the canvas themselves not being able to kind of define things external to themselves. That would include both anything visual as well as behavior. They would only be able to kind of define interfaces to the outside. And I would take that to an extreme and even include things like drop shadow as something that, like the assumption that that is not kind of semantically consequential is an assumption. Therefore, it should be kind of encapsulated. And anything outside of the geometry of an individual shape is kind of in this integration domain. And then the fourth one, which is really the the really hard bit that we don't have, is an approach to this actual process of integration, having kind of integration semantics, which is really just expressing relationships between these sets, regions, the objects that occupy them, and the systems that they are connected to. And I think it's probably important to note that these semantics are not really, they wouldn't really be part of the substrate itself. They kind of exist in an intersystemic sense, I guess, of being the connective tissue between all these things. So to illustrate this slightly, this is a bit like the physics example, right? Like having this notion of sets lets us, bind particular objects to semantics or systems and so on. But importantly, it does it in a way that is not kind of geometrically bound, right? So if we think about this in the traditional UI sense, often this kind of binding of some set of objects to some system would be through something like windowing systems, right? Where these you can't have this kind of situation of a bunch of kind of co-mingled interface elements connected to entirely different systems which aren't talking to each other and so on. So regions, I think, similarly simple as an idea, and it's just to say that we can define semantics in some subregion of a space, and this is kind of important for relating UI elements together. And you can imagine a really simple example that, if your interface has kind of drag and drop like the traditional canvas tools, that maybe dragging a piece of UI into a region, brings it under the purview of particular semantics, which could be as mundane as snapping to a grid, or it could be that the kind of the entire meaning of like colors and symbolic information changes. You could imagine, regions for different DSLs, domain-specific languages, and so on, that can kind of talk to each other. And also importantly with this, you're then able to have this kind of topological relationship between, objects in a canvas that are in different regions. And so as another hopefully straightforward example, you could imagine one region that's doing like some of the LLM text generation stuff that I showed, and another one that's doing I don't know, something more numerical and computational, and you can describe relationships between objects in those two spaces and kind of pipe information around, and you can quite quickly get to a lot of the kind of node and wire visual programming type interfaces, even though I don't think that's entirely the point, but that you can hopefully imagine it. So another important point with this is that we usually think of canvases as kind of empty space with all of the relationships between objects being explicitly represented in the canvas itself, like having an edge or an arrow between two shapes. But I think it's important to know that we can also kind of imbue the space itself with behavior or semantics. And so in this case, there is an underlying kind of relationship that these two shapes have to the space that they're in, which is then visually made legible when they get close to each other. So the last one, which I think is the really big unknown one here, right? But it's this question of kind of what semantics should we have for the integration of UI elements. It's maybe quickly just worth noting, in all these images, I'm using just boxes. So that's not, we need a lot more of that, a lot more than that for the kinds of interfaces that we want. So hopefully you can use a bit of imagination to see other things in their place. So one, I think, really good observation that Cal makes around why we need this kind of integration domain, and specifically why we need a kind of unifying medium for this this kind of concern of integrating these parts, in this case, parts of interfaces with each other and with the software that they connect to, is that if you take if you look at software for a second, and you take n different systems and you try and connect all those, you get something like a an n squared or an n squared problem into one of 2n or so. There's different ways you can do this math, but the point is that kind of naively connecting everything to everything else, it explodes in complexity very, very quickly, whereas a unifying medium, sometimes kind of known as like a narrow waist architecture, like TCP/IP on the web, it's one of the ways that you can kind of more fundamentally get around this problem. And so this is an old sketch, but I just wanted something to illustrate the point that he makes, or the what he argues for, which I wholeheartedly agree with, which is that whatever semantics we have for this process of integration, we really want them to be less powerful than the programming languages that we use for general purposes, right? So a way of saying that is that we want to express relationships. We don't want scripts or circuits. And so actually having languages that are sub-Turing complete is quite important here. And to illustrate that, this is a sketch from a slightly different idea, but you can imagine with this sketch on the right that you have a bunch of kind of underlying systems for your software. You have some space that all the elements are in, and then you have this something that resembles a network of relationships between the two, that is responsible for kind of choosing what's on screen, where it is, and so on. And so that stuff in the middle, as well as stuff in the space of UI elements in this particular diagram, would constitute the integration domain there. And contrasting that to the kind of model on the left, which I think I more or less outlined earlier, where you have these individual appliance-like boxes, and they connect to one or more systems. Yeah. All right. So one way of looking at this, I hope that this analogy will make sense to those here. I suspect it will. Is that maybe canvases could be to HCI what Haskell is to type systems research, where we can have many interfaces and interactions coexisting in the same shared environment. I think there's a lot of reasons to try and push in that direction beyond just end user software use. I think it can have benefits to our kind of collective ability to iterate on how we build UIs themselves. Although what I'm really advocating for here is not actually new UI innovation per se. It's that we hopefully can, and I think should, try and push to make the work that we're already doing and that has been done more integratable, as opposed to kind of remaining in its kind of siloed experimental state. So one way of visualizing that is, and again, this is an open question of what this looks like exactly, but we can imagine a different relationship that people have to computing, where instead of a single interface or a choice of individual interfaces, you have something like an integration domain and this kind of integration substrate, where you can bring in the pieces of UI that you need, and you can mix and match them, something that's a lot more amenable to change. All right, before I get to that second little demo here, just to kind of to recap this illustration, I think it's important to note that part of why I'm in some sense advocating for this direction and specifically for canvases is because I don't think that this is anything actually new, really. I think there's a lot of low-hanging fruit here, especially when we're looking at the web as the kind of the primary target tech stack. We have kind of some parts of this in like iframes and custom elements and so on. But I think the path to being able to bring pieces of the web together and UI made that way is not too hard to imagine, and I think we can do some experiments there, which I will quickly share now. How are we doing for time? Okay, we're doing all right. All right. So to kind of illustrate the relationship between canvases and kind of software customization and malleability, let's take this example. So this is Kel's website. Hopefully he doesn't mind. This is just a normal, entirely normal website. But what I have here is a button. You might not see much of a change there, but what's actually happened now is that I can now scribble on the website. I can do all the canvassy stuff, but I can also take the pieces of the website and move them around and, you know, we've basically decomposed the DOM into a bunch of subtrees, which we can now operate on as kind of individual objects in a canvas. And then if we want to, we can start doing things with these, like, for example, you know, if we want this in a different form, we can take it and pipe it into another thing. And of course, this is just using some crude LLM stuff behind the scenes to do this generation. But we're basically taking HTML as input, and we're producing new bits of, or new kind of perspectives on that. And we can do something maybe more interesting. Or let me actually just do one more thing first. So you could, just to kind of illustrate, because I think it's kind of fun. Let's do that. You'll notice my incredibly advanced UX here, where I just have to include the word HTML for this to work. So, I mean, this is just to demonstrate that we can kind of encapsulate styles in that, and you can get some kind of interesting looking results generated out of that. And if you want to,
so Orion, I want to stop you here because you're doing these flourishes, and I actually want you to say some things out loud a little bit more, especially for people watching this after the fact, so that
yeah,
we're clear. What's happening here is this is a regular HTML page, so you can look at the URL at the top. We're going to literally Kel's website,
yeah,
and then this is a browser extension, right?
yeah,
So it's a browser extension which canvassizes the whole thing, bringing in all of Orion's work, including the part where again, we're completely foreign to this interface. So he makes an arrow and then he types things, but wait, that's actually an LLM prompt in this domain. Yes?
yeah. Specifically in this domain, and I'm not advocating this as a UX paradigm, right? But the flexibility to have things like this, if this were useful to you.
This is a demonstration paradigm that really shows us what it means to remix content that we're already at. We're losing view source, and arguably view source was the wrong layer anyway, because we started arguing about tailwind or fucking semantics or whatever. And we put it up to a level where I, as a human, am being like, oh, I can play. I can do things. I'm bringing my tools to this space rather than somehow downloading the HTML, putting it in some other thing. So I'm doing things in place and
Yeah.
bringing in tools.
Yeah, I'm really glad you raised that point, because that's kind of one of the big ideas here is, broadly in line with the kind of local first and malleable software ideas. It's this idea of, what if you can bring the computation to you wherever you happen to be, in this case, wherever you happen to be on the web. And the system is reasonably generic to illustrate kind of what's happening here. I wrote a little thing. So what we can imagine is, so this is, a web page. There's some underlying DOM. And so what we can imagine is you have this DOM with all these layers, and then you're basically, through some CSS selectors, you're taking that and you're going to separate it out so that some stuff is brought forward into your canvas, the rest is pushed into the background. And then you go from this massive tree of many elements to a handful of elements based on kind of subtrees of that DOM, which is how I did that on Kel's website here.
Bill has a question, which is any of this permanent or published? Is it just stayed in the browser extension? Can I share this?
So right now it's pretty ephemeral. It definitely doesn't have to be. And there's a couple.
This is like 2 weeks old or 3 weeks old, right?
This one specifically is the last days in prep for this. I will
Deadline-driven development. Amazing. Love it.
exactly. Yeah. So similarly to kind of building different views, hopefully this works. We can imagine kind of generating or bringing in previously authored UI. And so in this case, we have one that will randomize the text in the thing that's pointing to it. And what I tried hard to do today to get ready for this, but didn't quite make it, is to demonstrate that you can pin these, well, something analogous to that, right? So the idea would be, you can take
Make a
something.
UI.
Yeah, you can just be like, you hit a button, you go back to the normal website, but that particular button is persisted and gives you the ability to retarget to other elements. So it's like, oh, you really like the colorization that it does. Okay, now as you're scrolling through the website, you can point it to another paragraph and it will colorize that.
And ideally, this becomes a component itself that you might publish that looks like user scripts, but really this is computation plus UI together. That over the domain of other users, you might have a type of library that you do stuff.
Yeah.
Right. All of these things become, and I think that's probably why Bill is asking about that. We can do many single user flourishes, and what we need to get to is that space where we can go from our space to shared areas in multiplayer as well.
Yeah.
Bill, I think asks, how might you use this in cross-page curation? I'm just going to say we've gone down this path before, and you'll go into it in the rest of your presentation. This is us actually going, instead of stovepiping an app with one system, let's say we call this Orion Net. Orion doesn't want this to be Orion Net. He wants it to be everyone net, which means
Exactly.
that we have to do the really hard work of going like, okay, where are we going to componentize this at the layer so that it can get reused?
Exactly.
Right.
And that's kind of where I'm going to come back to towards the end of this, because exactly that, right? Like, all of these are demos, and maybe I want to do stuff with this, maybe other people do as well, but this is meant to be a kind of illustration of something that we would like to exist in a well-developed integration domain. Like, we would like this stuff to be easy, and remixable with stuff that has entirely different semantics, right? Where you don't have arrows, and maybe you can't pan around and you can't scribble, but you can do a bunch of other different things. We want to support all of these things in the same shared environment, and that's kind of really the point. And on that note of kind of cross-site integration stuff, as a very tentative example of that, we could, for example, take this really long dog, do the same thing over here, and now we can take apart the dog. Get a nice long bit of dog here, and then we can we can just, in this case, copy paste that across over to here. And you could do the same with a piece of UI. You could copy that over here. And if I had the ability to retarget this, you'd be able to, randomize the color of the dog, for example.
Yeah, and I'll just, because I rant about this on these calls all the time, so I'm going to bring it up again. Is again, this is akin to me, some of the things that people gasp at, right? Like, remember, it actually, it'll look more interesting when you have the two browsers next to each other and you drag and drop between them. We actually have the technology. TiddlyWiki, between two TiddlyWikis,
Yes.
does this,
Yeah.
right? And that's been one of my long running things that maybe, now that I've got a little more time, might be something I get to, is what if several of us built tools that accepted a drag and drop, right? And that's exactly the point of, like, oh man, I have to build my entire system, and you papered one over the top.
Yeah, that's kind of part of what is maybe interesting
Yeah.
about this direction specifically, is that this, normal web elements or even custom components, custom elements with web components, can be made to work this way, even if a website wasn't designed for that. Some websites are going to be harder. Something like Google Docs is more or less impossible because it renders everything to a canvas, and there isn't enough information on the client side. But for a lot of the web, this works totally fine. And so this idea of actually, instead of having a dedicated piece of software that you then have to live inside of, having a kind of an information substrate that you can interoperate with almost no effort. There's lots of ways the websites could make themselves amenable to this kind of stuff if it became a wide way of doing things. Even as simple as just adding an agreed upon class to elements to define for that website what the route should be to select the subtrees, right? Right now I use very crude heuristics. So there's...
So before I have you here, Jeffrey Litt has a question, and then we should get back to the rest of your presentation. Can you compare the canvas with other possible substrates? What do you see as the strengths or challenges?
Yes, I think that's kind of the important question. And I will answer that, but I'll answer it at the end. I think I even have a slide for it.
Amazing. Thank you.
All right. And this is actually towards the end, that there is a final bit which I will mostly breeze through, because it's more of just like a flag to plant, because I think it's interesting. So to summarize the important stuff here, right? I think what I'm kind of pitching is that developing an integration domain, if we believe that such a thing can exist for HCI or should exist, can enable new software topologies which are more malleable, flexible, pluralistic, or heterogeneous, and I think also fun. I think, for reasons that we can get to in the discussion, that the spatial canvas is particularly well suited to be a foundation there. And we'll get into why in just a second. I will breeze through the last thing because I know we're low on time. So switching to dark mode here, because we're talking about fun ideas and there's many slides already. So this kind of comes out of this observation that a bunch of view changes are discrete in our interfaces, right? Like this is Obsidian, like a note-taking app. You have this graph view on the left. You have the note view itself on the right. Some are continuous. If you go from the graph view and you zoom in, you get new information, and then you can click on one of these to go into the full view. And my kind of fun question here, hopefully fun question, is can we better understand the limits of these kinds of transformations and the ones that are continuous in particular, and kind of build languages or systems around that? So we could imagine, for example, in this case, taking out the middle part here and replacing it with something that has a kind of continuous function or continuous transformation to either side. And then if you do that, you've defined a kind of a fully continuous transition from one view to the other. I will actually skip this one because I didn't make a demo for it. I'll leave this GIF though, because it's great. This is from Andrew Blinn, which is looking at kind of, how you can see the same thing from different perspectives. And the transitions here are they're semantically rich. They're not like visual flourishes for animation's sake. For lack of a better term, I welcome suggestions. I've been calling these kind of like visual semantic morphisms, which is a kind of transformation where you're preserving the semantics throughout. I will also skip that one. And I did manage to scrape together one final demo, which is, imagine that this is your like Obsidian graph view, and we want to go into graph mode. We can transition between a purely kind of point-based graph layout and one with labels where we have no information. But in this case, the semantics here are that the label is inside, because we want to then persist that kind of encoding of the semantics to other views. Like we can go to this kind of mini note view, and I think, did I remember to make these editable? Maybe I didn't. But you could, for example, see a bunch of notes kind of clustered together and edit them. And then, of course, if you wanted to, you could go to a full screen view or one that's close to full screen. So this was just to illustrate that it's conceivable that in a world where we have more of our UI in the same environment, that it could be it could be a kind of a patchwork collage of different things where you have your email client of choice next to your tree view thing of choice for whatever purpose, and you have your all of the stuff together kind of with all of its own visual
I will say that in many ways, when we think about this as integration domains, I think the other thing that's been coming up a lot is people have been bringing up this the word operating system to things that are not like running on hardware, but much higher level. Notion is talking about Notion OS and various things like that. And that also reminds me of this is somewhere hidden in here is can we in fact replace windowing systems with this?
That's a really good point that I probably should have made, right? Is that part of, I think, my attraction to this idea in particular is that we don't need to replace windowing systems. We can kind of build it within the constraints that already exist. But ideally, long term, it feels like windowing systems are something that eventually needs to be replaced, which is not to say the idea of Windows needs to be replaced. There are
Spatial
many times where
computing,
you might want that,
spatial
but it should be a
computing.
choice.
I'll let you continue.
All right. I will wrap up here. I think we only have one more slide.
We're good. We're good.
Yeah. So I mean, and again, this thing does not exist. I'm hoping we could build it. That's why this diagram looks like this and is a diagram and not much more than that. But we can imagine, hopefully now, or more easily imagine a way that we can get to a world where you can have many different interface elements, many different pieces of these systems visually represented together in a way that remains cohesive in the sense of being as accessible and as useful, as understandable as the stuff we have today. So yeah, like this is the pitch, that we can abolish apps in the kind of the sense of how we relate to that interface. Pick whatever words you want, and we can turn them into compost and build other interesting things. I was thinking a lot about compostable software when I wrote this last slide. There are some links if you want those. I will close out there, but to jump on Geoffrey's point, I think I did have a slide which is unfinished, so you'll see my some of my notes here. So when we're looking at comparing this to other approaches to doing something like an integration domain for HCI, I think there's a few things that it gets us. I'll just mention two. So one is the kind of uniform address space that it gives you of shapes on a canvas and their relationship to well-defined geometry. So it's possible to build a substrate like this where there is always a clear inside and outside when you want there to be. and that makes it much more possible to bring very different elements together in a way where you can make kind of stronger guarantees, right? So connected to this is this note in the middle here, which again, this is not a real slide. This is one of my notes. Is that one of the challenges of kind of traditional layout on the web and trying to imagine how we bring together multiple interfaces is that the DOM layout is kind of overpowered. Shapes can, you know, that if you're a DOM element with some inline styles, you can say like, yeah, my width is the full width of the screen, and I'm in front of everything else, like the maximum Z level and so on. And so it means that it's more or less impossible to robustly bring together elements from different authors. And I think without that, it's hard to imagine kind of building something like this. And so that's kind of where we have something like this idea of geometric encapsulation. The last thing I'll say, and then I'll finish up, is I think that the kind of the structure of a canvas as this quite plain Euclidean space is not. I think that the way to think about that here is not that that is what we ultimately want. We don't want everything to be a kind of absolutely positioned, plain, empty space or whatever, but that it is actually more useful when it comes to this task of integrating UI to have something much more that is less opinionated about layout, right? You have a shape, it has some position. There is not much more than that. Because it means you can bring in these other systems that you want, whether it's a graph layout system or Flexbox stuff, or much more kind of complex and advanced ideas. But I think that kind of, in some ways, the blandness of the Euclidean space of a canvas is actually an asset when it comes to being an effective substrate for integrating UI.
Jeffrey,
Yeah.
any thoughts, or would you like to unmute and
Sure, yeah. Thanks. That was a helpful answer. I wonder, those are the strengths. What do you think are the challenges? Like, I guess one answer might be like the DOM does helpful stuff. Like nesting seems like one example. Like, how do you do nesting? Is it just a new layout algorithm you have to like add on to the canvas, or how do you think about that?
Yeah, so I think there's at least a couple answers there. So one is that you could just use the DOM if the nesting you're talking about is local enough. So like in the web browser extension example, any existing DOM layout stuff will still apply within that element. It just can't say anything about where that shape is. Like like the shape is not allowed to move itself over to the right or to do stuff outside of its borders. And then the other one kind of comes back to that question of like what semantics are appropriate for an integration domain in general. That's not a question that's going to be like a solved question for the foreseeable future. But being able to express those kinds of relationships, I think is important there, where you can just being able to express, hey, like this object over here is inside this one over here, even though I'm sure there's many interpretations of kind of what inside means, and that may well be kind of context dependent, which is where you need.
But I think that's exactly what your
other...
point by bringing up the 3D DOM browser.
Right.
All this stuff is there, and then you could layer on different expressions of it. I'm reminded of concepts of memory palaces generally, which aren't usually visualized. And the other thing that I think a lot of us need to spend a lot more time thinking about spatial computing. Right? Like this is the other part that's also coming, and that comes down to things like 3D engines and gaming engines, which are a very different even set of people of how they think about things. And I think the flat infinite 2D canvas is the first start of like, oh, right. It's not a piece of paper.
Right. And maybe this is an overly obvious thing to say, but it's worth pointing out, right, that like ultimately that's kind of what we have already, in the sense that most screens are two-dimensional bounded Euclidean spaces, right? If you were to replace the DOM, layout systems with absolute positioning and stuff, you'd be a long way towards having what we think of as a canvas.
I want to pause first of all, and basically just before people drop off, you're welcome to stay on and just say, Orion, thank you so much. That was awesome. And for everyone that doesn't know, this is sign language for clapping, so you don't even have to unmute yourself. That was super fantastic. I'm super glad that we do have a recording in space. Thank you. Any other questions that people have? Awesome. What I'm going to do is, we can still hang for a bit. I'm going to stop the recording. Thank you everyone for joining us. It will be sent out with links and everything else to all those people who signed up. And we will see you for a future TFT Rocks.